the curvature of a plane curve. Here we will find the solution, how to derive the formula for curvature of a curve if given in the parametric form. So there is a formula we are using for curvature if the curve is given in the parametric form. That is, if x is equal to xt, y is equal to yt are the parametric equations to a curve, then at any t, the curvature kappa is given by x dash y double dash minus y dash x double dash its modulus divided by x dash square plus y dash square raised to 3 by 2. So this formula we have to derive. Now here the curve is given in the parametric form xt, x is equal to xt, y is equal to yt. Then its vector equation is given by xti plus ytj is its vector equation. And if the vector equation is given, the curvature at any t is given by kappa t is equal to modulus of r dash t cross r double dash t divided by modulus of r dash t the whole cube. So here rt is xti plus ytj. You find r dash t cross r double dash t first. R dash t cross r double dash t is equal to, you can write it as a determinant I, j, k. Here rt equal to xti plus ytj. So r dash t is actually x dash t I plus y dash tj, and r double dash t is x double dash t I plus y double dash t j. So r dash t you can write, component you can write x double dash x dash t y dash t 0, and that of r double dash t is x double dash t y double dash t 0. Expanding with respect to the last column, we will get this is x dash t into y double dash t minus y dash t into x double dash t. It is modulus of that into k. Sorry, into k. Into k. Therefore, modulus of r dash t cross r double dash t is equal to, when you take its modulus, we will get x dash t I into y double dash t minus y dash t into x double dash t, its modulus. Simply, we can write this as x dash y double dash minus y dash x double dash modulus. And what about r dash t? You know, r dash t, its modulus is, here rt is xti plus ytj, therefore r dash t is x dash ti plus y dash tj. Its modulus is square root of x dash t square plus y dash t square. Or simply you can write this as x dash square plus y dash square, and therefore kappa at any t is equal to formula modulus of r dash t cross r double dash t by modulus of r dash t cube. R dash t cross r double dash t is modulus of x dash y double dash minus y dash x double dash divided by square root of x dash square plus y dash square raised to 3, and this you can write as modulus of x dash y double dash minus y dash x double dash divided by x dash square plus y dash square raised to 3 by 2. Now let us derive another formula This is problem 6. That is, let y is equal to f of x be a plane curve. Show that the curvature at any x is given by kappa of x is equal to y double dash divided by its modulus, actually 1 plus y dash square raised to 3 by 8, where y double dash is d square by dx square and y dash is dy by dx. This is dy by dx and y double dash is d square y by dx. So if the curve is given in the Cartesian form, you have to derive the formula kappa x is equal to y double dash plus 1 plus y dash square ratio. This formula we have already used for solving certain problems. So let us find the solution here. Here the curve is given in the curve is given as y is equal to f of x. Actually, x is the parameter here. You can take, by writing this y is equal to f of x in the parametric form, you will get x is equal to x and then y is equal to f of x. Instead of x equal to xt, y is equal to y of t, you can write this as x is equal to x and y is equal to f of x. Therefore, the vector function corresponding to this Rx, here x is the parameter, Rx is equal to xi plus yj, that is y is equal to f of x, where y is f of x, xi plus yj. Now, if use the formula kappa at any x is given by modulus of r dash x cross r double dash x divided by r dash x the whole raised to 3. You will get kappa x. So what is r dash x? R dash x is equal to I derivative of x I plus derivative of y with respect to it is y dash j, and r double dash x is equal to, this is 0 plus y double dash j. Then r dash x cross r double dash x is equal to determinant I j k, r dash x, it is 1 here, coefficient of I1, coefficient of j y dash, and the coefficient of k 0, and that of r double dash is, there is 0 here, this is y double dash, and this is also 0. So expanding this with respect to the last column k, you will get 1 into y double dash minus 0 into y dash into k. That is 1 into y double dash minus 0 into y dash into k. And therefore, modulus of r dash x cross r double dash x is equal to, this is only y double dash. So it is modulus of y double dash. Modulus of k is 1. So it is modulus of y double dash. And r dash x is I plus y dash j. Therefore, modulus of r dash x is equal to square root of 1 square plus y dash square. That is equal to root of 1 plus y dash square, where y dash is dy by dx. Hence, kappa is equal to modulus of r dash x cross r double dashes, which is modulus of y double dash divided by r dash x the whole cube, that is root of 1 plus y dash square the whole cube. It is equal to modulus of y double dash divided by 1 plus y dash square raised to 3 by 2. So this is the curvature at some point x. Actually, it is curvature at x is given by d square y by dx for its modulus divided by 1 plus dy by dx whole square raised to 3 by t. If the curve is given in the Cartesian form, y is equal to f of x.